G'day everybody. This is a continuation on our lesson on distributions and random samples. It's really just a chance to go through a few examples so you can see how we use distributions to talk about samples and probabilities. So in that lesson we talked about how statistics behave when we take samples from a population, and it was very much about how do we model the randomness of those proportions, and there are two models that we looked at. So sometimes we use a binomial distribution, sometimes we use a normal distribution. There is a rule of thumb about when you use each distribution, but just for the purposes of assessment of the exams, examiners will tell you whether to use the binomial or whether to use the normal distribution. So we're going to look at this problem. You may want to pause the video and write the question down and have a go at it yourself, and then we'll talk about the solutions. If that's the case, you can pause it now. But let's press on and have a look at how this question would be solved and how we would respond to it. So in this question we're talking about a proportion of Australians with red hair, which is 15%. We would call that the population proportion or the population parameter. And we're going to take a sample of 16 people. Based on that 15% and based on the size of the sample, we're going to find the probability that the sample proportion given by this p hat is greater than 0.5, and we're going to find the probability that the sample proportion is greater than the population proportion. And for this question we are using the binomial approximation. Because we're using that approximation, I'm going to start by defining x, which is the number of people in the sample with red hair. It's binomially distributed. We've got 16 trials, or 16 people in the sample, and the probability that each individual person has red hair is 0.15. Our first question is about the probability that this proportion is greater than 0.5. So I'd like to know what is 0.5 of the sample. Obviously that's going to be 8 people. So here's the answer to that question. You'll see how I've framed the question about the sample proportion in terms of the discrete probability, the discrete variable x. So the probability that the sample proportion is greater than 0.5 would be equal to the probability that there are more than 8 people with red hair in the sample. You might do this because it sort of helps you think about what you're going to do on your CAS calculator. That means we're looking at the probability that x is some value from 9 to 16, which would be the lower bound and the upper bound when you use the binomial CDF function, and using our value of n, our value of p, that gives us a very, very small probability of 0.00016, which sounds about right. 15% of Australians have red hair, so taking 16 people and thinking about how likely is it that more than 8 of them would all have red hair would be very, very low. In our second question, we're making a distinction between p hat and p. P is the sample proportion in the 16 people. P by itself is the population parameter, the 0.15. So we're going to use our discrete distribution. We'd like to know what is 15% of the sample. So 15% of 16 is 2.4. So framing the question about the proportion in terms of the discrete variable, the probability that our sample proportion is greater than p would be equal to the probability that x is greater than 2.4. And because x is a discrete variable, that means that we're looking at the probability that x is anything from 3 to 16 in that sample. And again, using our binomial CDF function, that gives us a probability of 0.439. We're now going to look at these two questions. It's about the same context. We've still got a population parameter of 15%, but this time we're going to randomly survey 160 people. And it's typical that if we had a bigger sample size, we would use the normal approximation. So we're going to use the normal approximation for this question. Here's the two questions that we're going to answer. If you'd like to pause the video now and have a crack at that, now would be the time. So because we're going to use the normal approximation, we need to find the mean and the standard deviation based upon the information we've got about the size of the sample and the value of p. So our mean is our value of p, so the mean of our normal distribution is going to be 0.15. We're going to use our formula for the standard deviation, which would be 0.15 multiplied by 1 minus that, which is 0.85, divided by 160. We'll take our square root. Gives us a standard deviation of 0.028. So now we've got our mean and our standard deviation, we're in a position to start using the normal approximation. So it's a good idea to define your sample proportion as a normally distributed variable with a mean of 15, standard deviation of 0.028, and the probability that the proportion is greater than 10%, less than 20%. We're going to use our normal CDF function on the calculator, and that's going to give us a probability of 0.93. So a very high probability, which sounds about right when we compare these proportions to the population proportion, which is 0.15. The second question, what is the probability that less than 20 people in the survey have red hair? In this question, it's no longer a probability about the proportion, it's a probability about the discrete number of people in the survey. So we're sort of working the other way now. If I'm looking at the probability that x is less than 20 people in the sample, and I'm dealing with a normal distribution about the proportion, that means I want my proportion to be less than 19.5 out of 60. I'm not using 20 out of 160, and I'm going to explain why on the next screen. But that's going to be our sample proportion that reflects the probability that x is less than 20. And again, with the normal CDF function, and we're going to use negative infinity for our lower bound. Our upper bound will be 19.5 over 160. That gives us a probability of 0.16. So let's have a discussion about why I chose 19.5 out of 160 to reflect the 20 out of 160 people in the sample. It's a little tricky, but we're thinking about inclusive integers. And the way this has come about is because we're using a distribution which is continuous to give us answers or approximate proportions about discrete quantities. So let's say we're talking about a sample size of 200 people. If we were looking at a question that said what's the probability that we'll have from 20 to 30, that's our discrete number. From greater than or equal to 20, less than or equal to 30, our continuous proportion, sample proportion, needs to include 20 and 30. But because it's continuous, it needs to be inclusive of everything above 19.5 and everything up to 30.5. So down here, what I've shaded on that number line is the continuous proportion, and what we can see in the numbers in the background are the discrete quantities that are going to be included in that continuous proportion. So greater than or equal to 20 means I've got to start at 19.5, halfway between 19 and 20, and up to 30 means I need to include everything between 30.5 down to 19.5. If I was going to use the words between 20 and 30, suddenly that changes the signs to less than, not less than or greater than or equal to, but just less than. And so it now no longer includes 20. And so now my proportion, we need to adjust this. So not including 20 and not including 30 at the upper limit. But we're starting at 21, finishing at 29. So our proportion has to taking everything from 20.5 to 29.5. I'm not sure if I explained that really well. It might be a bit tricky, but it's something you have to keep in mind when you are talking about continuous distributions and discrete distributions at the same time. That's all we're looking at in this video today. There's no Google form for this lesson, just incorporated with the first video in this lesson. Thanks very much.